Hello and welcome back to module number 3. We are going to talk today about metrics, data frame, and in the end I will also start talking about what is a package and what makes the package so powerful in R. And I'll try to show you what is the outline of the package and why is it so important and what makes the R so powerful application when you can run multiple package at the same time. So let's start with metrics. And the idea of a metrics, it comes from just a note. In module number 1 and 2, I introduce you to the functions and vector, and I hope that it will make more sense. I will post on Sunday evening, I'll post the answers to module number 2 assignment when you had to write functions for your first time, and probably most of you encounter some problems, but it is only the technicality of how you wrote the function that makes it so hard. I will try to go over that. I will try to make sure that you understand in order for you that in the future you will not run to it. I would like also to ask that you will post it on GitHub in order for you to remember what make the mistake in the writing of the function in this assignment and what did you learn out of it in order for you to avoid future mistakes when you assigning value or assigning name to the function. So back to our discussion. And metrics, we are going to talk about metrics and data set. In mathematics, a matrix is called a collection of numbers arranged into a fixed number of rows and columns. In R, it's also the same thing, but with regard to the data elements that we embedded into the R. So it is basically a two-dimensional layout that we are calling matrix. So in algebra, we have the idea of the column and the row, and we have the size of the matrix that we are able to calculate with multiply of m multiplied by n, which is the number of rows multiplied by the number of columns. And the idea here is that when we do manipulation of matrix, we are considered to be a circular manipulation. So we define what is a circular. In this case is a two columns, and by doing that we are able to set up the calculation. So the circular of A is a matrix, and then the circular of SA is the matrix whose columns are S times the corresponding entities of A. And in other words, you are able to calculate the matrix when we have multiple rows or variables in it. The theorem behind the circulars are usually defined in the following formula: R plus S multiplied by A, and we divide it by RA plus SA and R multiplied by SA, which is equal to RS multiplied by A. So basically we have ability to calculate the matrix and be able to find out what is the value of it in that sense with regard to mathematics and in regard to know where we are with regard to the number of rows and columns that the metric represent. In R, the same thing. And again, I am going back to our textbook in chapter 3 and 4. So he gave you example of array, which consists of numbers to 1 to 25, but he gave you another description of the matrix. He calls it dim. And in this case, the dim has to have 3 rows, 3, 4, and 2. And in order for us to display it the way we want to show it in the numbers that are selected for us 1 to 24. So in this case, this is how it displayed, and this is how it shows up in the matrix in R. So creating a matrix in R, usually, again, I call the function y, and the matrix is 1, 2, 3, and 4, and the number of row is 2. So if in this case I will ask the R to display my matrix, it will display it as I lay out for him in the following manners. So in this case, it will give me 2 columns as I ask, and it will consist of the numbers between 1, 2, 3, and 4. And by doing that, it will allow us to do that. We can also cut or display part of the matrix. And again, this is for those who wants to show only part of the matrix. And so again, this is how they are able to do that. This is a shortcut. And so I want you to be familiar with the idea of the shortcut in that sense. What does it include? The general matrix operation in R is also about linear operation and also about the matrix indexing. And the third one is the matrix filtering, which means all of them are part of how we able to manipulate the matrix to work on our side when we have more than one calculation to conduct. And so again, simple matrix in R, and again, I giving it number of rows, which is in this case 3, number of columns in this case is 3, and I want it to have integers 1 to 12 in 4 columns. And so this is how it will allow me to do that. And you have the ability to be more specific in your command to the R with regard to the columns or how it goes about with that sense. A different look, we will use the BW row as true, and it will give us the idea of how it be applied beyond that. And again, this is how it apply and how to look at that. Another way to look at it from a different dimension is the dim. The dim display the dimension of x. So in this case, the dim will be based on the 4 columns and the 3 columns instead of what the matrix allowed us to display. A different look on the matrix is based on indexing. So you can access the elements of the matrix using square brackets, which is indicating of the indexing. So the element can be accessed by the variable row and columns. So it is possible to use the matrix as integer as the index. So in this case, you will be able to display more extract of the elements and how it display. So in this case, the matrix in this example is 1 to 4, and I'm going to say 2, and which means 2 columns or 2 rows. And so in this case, it will give it to me. But in this case, I'm going to apply different function or different calling to how I want this matrix to work. So I'm going to give it another name, and I'm going to call it I, and I'm going to say matrix, and I'm going to give it some values, and I'm going to say by row, which will be true, and it will give us what it consists of. So that's the idea of dim, and this is how the dim works in that sense. Negative values is also an issue that is not allowed in the indexing matrix. So NA or 0 values are allowed in the rows of the index matrix containing a 0 are ignored, where the row containing the NR produce an NA in the result, which means in this case I can do filtering. In addition to that, I can do filtering to the matrix in order for me to get again to narrow down, to make more specific with regard to my request. So the filtering is another stage. I did not show you example of negative values, but in the following example, I'm showing you the filtering. And the filtering is another dimension, again, to the power of the language as part of our narrative in order for us to get more specific values that we are looking at. And so in this case, I'm going to use minus negative numbers, and in this case the z is 5, 3, minus 3, and 8, and I will go to call w, and I'm going to go to the z, and I'm going to multiply the z, multiply itself, and I'm going to say that it will be smaller than a. And so in this case, he will filter out for me the matrix in order to it to show. Our textbook provide the following example. And again, he is not narrative, is not negative numbers, but again, look at the example, see how it can play out when we are doing the filtering to the matrix in order to get more narrow result than we are usually following just the matrix. But we also can do another element that no other application can do, which is the matrix in linear algebra. So here is a simple example in algebra operating in R. And in this case, I'm going to use something that we will encounter again and again throughout the semester, which is percent multiplied by percent. And in this case, I'm going to show you the example. You're going to apply the example, but I want you to remember that because this is something that will appear again and again, as I said before. So y percentage multiplied by percentage y, and I'm going to do multiplication. So in this case, it will give me different values, and in this case, I'm going to do 3 multiplied by y in order for me to show you the value of the linear algebra by using this scalar application in algebra. And in this case, I'll be able to add or I'll be able to manipulate the data based on the linear algebra that we or learn in high school how to apply that. So the result holds the value of y as a matrix with the idea of the linear algebra. So now we are coming to the big subject of this module, which is a data frame. And R is often stored the data frame because it can apply multiple types of data in one data frame. So the definition of data frame is a table or two-dimensional array-like structure, which each columns contain measurement on one variable and each row contain one case. Unlike array, which we learned or talked about in module number 2, the data that stores in columns of the data frame can be various types, which means that it can have numerical type, it can be text, and it can be true or false. All columns have the same length with regard to the same number of items stored in the database. So the database I used to store represent all types. Unlike metrics, the data frame can also classes of object in each columns. And the data frame also have a special attributes called row names. Row.names allowed us to annotate the data. And again, this is additional element that we are usually missing when we are using our calculation in Excel or SPSS or any other application. And one of the benefits of the data frame is it can be converted into when you say to the R, read this table or read this CVC or Excel file, it can convert it into data frame by using the following. So let's take a look at this. Data frame, I'm going to call it DF, and I'm going to say data frame, and I'm going to say face equal C, and I'm going to give this, the first one is ace, 2, and 6. This is words. And then I'm going to say another words, food. What type of food? Breakfast, lunch, and dinner. And I'm going to also add values, numerical values to those terms. And I'm going to give it 1, 2, 3. So basically, the data frame will be able to display this set or three different set into one matrix table. So in this case, it shows up what it will contain. There is a syntax to the data frame. And so this is the outline of this data frame, the DF, the data.frame is to check if the object is a data frame, which is important, very important. The dim is to get the dimension of the data frame, as I discussed about the matrix. The str is to get the structure of the data frame, because if you are getting a data frame from other packages, it's usually very good to check to see if those data frame actually follow the idea of the vector, the same length, the same row, and so on and so on. So it's really important as a quality insurance to make sure that it is correct. So again, we have the ability to identify. I want you to keep this syntax in your memory, because if you're going to use data frame in your package, it's good to have that. So how to change a data frame row and columns names. So this is, in other words, you can set a header in your data frame. As a result, you can see the names of the variables appear in the data frame. So in this case, data type, vector is a sequence of elements at the same type. Matrix is the rectangular array of data arranged in rows and columns. Array are similar to matrix but cannot have more than 2 dimensions. Data frame is a more general than the matrix, and it contains different columns that can have different models of data: numeric, character, vector, or factor in that case. List is the order of the collection of objects, and factor is a vector whose elements can be taken one specific values. So the data object in R, again, the vector is 1 dimension, the matrix is 2 dimension, array is 2 or more dimensions, data frame is 2 dimension, but it will allow us to embed it into the data frame more than one collection. And a list is a collection of data object. Each element is a list of data object. So in simple display or a visual display of what I have been talking about, the vector 1 dimension, the matrix is 1 dimension, the data frame can hold multiple set like array. So this is my introduction, and in my assignment to you, as you're going to encounter, you're going to have different elements of it and see how to do that. The last section of this module is a package. So what is a package and why is it so complicated compared to what we are accustomed to do? When you are using Excel and you want to extend the type of visualization, you do not have this extension. So the packages basically is the extension of the open source R, or in our case, RStudio. So everyone can actually create this package. And if you will go to Crane and you will see the list of packages available to the user, you will probably find more than 10,000 packages out there, which is quite a lot when we are talking about a worldwide distribution of RStudio and R in the world. But the thing is that it allowed us to produce a lot of specific packages that allowed us to concentrate on specific tasks that usually most people do not use. Example, I created the Lotka's Law. Lotka's Law is the idea of counting how many citations an author has if it can be searched in a bibliometrics data set. No one needs that. Yes, people in the academic might need that, but people outside the academic might not need that. So it is extension to the RStudio. It is extension to the ability for us to apply that. And the interesting part is that this is the freedom that open source R and the RStudio give us when we are doing that. So how do we install? Usually we have two types of repositories. One is the Crane, which is belong to the R community, and the other one, which some of you are coming from biology and natural science, can relate to. It's called Bioconductor, and it is usually about science and about, example, physics and chemistry and biology. And again, the number is growing. In RStudio, in order for you to install a package, you need to type the name of the package. When you first installed the RStudio, it gave you a list of packages already embedded into the RStudio. So some of it that we will use throughout the semester, example, ggplot, that allowed us to do the visualization, outstanding visualization, already embedded into the RStudio, so you don't need to. But if you want to search for new packages or new ideas, I recommend you to do the search on packages and also do search using the RStudio to new packages and how people name them. So again, today we talked about Data.Frame. You're going to have an assignment on Data.Frame. I gave you specifically directions on how to apply the Data.Frame step by step. If you have problems, please let me know. And we are going to start talking about, from now on, we are going to start talking about the structure of the programming. So this is basically the foundation of R. We cover it in module number 1, 2, 3. And now we are going to start talking about the next module. We're going to talk about the more advanced application of R. So until next time, I hope you are warm and you have a warm place to stay because the weather temperature is going down in Tampa. Until next time, have fun and enjoy.